Number System Introduction Part 3. In our earlier videos, we understand about real numbers, that is irrational and rational numbers. In this video, we are going to explain the decimal expansions and the conversion of recurring number into fractional form. Decimal expansion. Decimal expansion will lead us two forms of decimal number. One is terminating and second one is non-terminating or recurring. Let's see an example like 7 by 8. Let's divide 7 through 8. We get, like you know, that 7 is not going to be divisible by 8. So, I add a decimal. As a result, I can add a 0 beside 7. So, it becomes 70. Now, we know 8 times of 8 will give you 64. As a remainder, we get 6. Again, for the decimal, I can receive 1 0 more. And we know 7 times of 8 will give you 56. And it leads to another remainder, that is 4. For decimal, again I can add a 0. And we know that 5 times of 8 will give you 40. As a result, you do not get any remainder. Hence, 7 by 8's decimal expansion is 0.875. Let's take another example, that is 10 by 3, which is a rational number, and let's see the decimal expansion of this number. Let's divide 10 by 3. We know 3 3s are 9. So, I have get a remainder 1. As you know, 1 cannot be divided completely by 3 as 1 is smaller than 3. So, I add a decimal. For that decimal, I have added a decimal. For that decimal, you can add a 0. So, again 3 times of 3 will give you 9. Again, you are getting remainder as 1. Again, for decimal, you get 0. Again, you can multiply 3 by 3. So, you are again getting 9. And again, you are getting remainder 1. So, this process will continues. As a result, you can say that number repeats after decimal, that is 3. So, 10 by 3, the decimal expansion is 3.33333 and so on. So, this is an example of a recurring number, or you can write this number in the form 3.3 bar. I hope you understand how to expand in a recurring form. Now, let's see the another part of this video, that is the conversion of recurring number, that is non-terminating recurring number, to fractional form. Let's take an example of a recurring number, that is 3.33 ... or you can write it down 3.3 bar, which is a representation of a recurring number. Let's consider let x be a number which is 3.3333 and so on, and let's mark it as equation 1. Now, we are going to multiply it by 10 to this equation 1. So, equation 1 is multiplied with 10 and you are receiving the new equation, that is 10x is equals to 33.3333 and so on. So this is your equation number 2. Now equation 2 minus equation 1. So equation 2 minus equation 1 will gives you 9x in your left hand side, and in the right hand side you are getting 33 minus 3, because after decimal portion it will be totally omitted. Then x is equals to 33 minus 3, that is 30 by 9, or you can write it down as 10 by 3. See, that's your fractional form. Let's take another example. The example of, like, let's take a number like x is equals to 1.272727, or as so on, or you can write it down x is equals to 1.27 bar. Now let's do this. So as I have considered this equation as 1, so I will multiply equation 1 by 100. Why 100? Because after decimal there are 2 digits which are repeating, which are in the recurring form, that is 2 and 7. So that's why we are going to multiply it by 100. So 100x is equals to 127.272727 and so on. So this is your equation number 2. Now I am going to subtract equation 2 by equation 1, equation 2 minus equation 1. So I will get 99x at your left hand side, and right hand side it will be 127 minus 1. So it is your x is equals to 126 by 99, or you can simplify this and you will get that is 42 by 33, and again if you divide the entire numerator and denominator by 3, you will get that is 14 by 11, which is the fractional form. So I hope you understand. So stay tuned for the next part of this video, part 3. Thank you.